Welcome to Unshielded, the podcast where we explore the cutting edge of blockchain, data protection, and the quest for a more equitable and accessible internet. Today we have a fabulous guest joining us, Jonathan Sobel, architect for Midnight at Input Output. Jonathan is a seasoned expert in software architecture and has helped the design and deployment of some of the world's most complex systems. In this episode on Midnight Fundamentals, we'll explore the technology that underpins Midnight, data protecting smart contracts, and get a hands-on demo that will show you a working DApp on Midnight. Jonathan, welcome to Unshielded. How are you doing today?
I'm doing great. Thank you for having me here.
Very happy to have you here. Thank you so much for joining us. You had an impressive career in software architecture and with blockchain technology. Can you share with us what initially drew you into the field of data protection and blockchain?
Yeah, so I wouldn't say a great career in blockchain because that is not my background. So I am a much more traditional software architect, a background in programming language design and implementation, and I've worked in storage management and risk management and regulatory compliance and business collaboration systems and networking and just sort of building systems, lots of building systems. None of that has been cryptography, none of it has been blockchain, none of it has been Web3. And so that is not my background, which might make you go, wait a minute, why did they get someone who doesn't know blockchain stuff to be an architect on this system? Oh no, it's going to be a disaster. But in fact, one of the fun things of working on this has been that there's a team of architects. And so, for instance, just as an example, say Thomas Kerber is one of the architects. He's the person who wrote the Kachina paper, that designed the kind of central innovations that give you control over data sharing. And we have other people who have expertise in other areas of it. And so I have come to it in a sense as someone from outside that world, bringing some more what people think of as traditional system engineering to this. And I hope bringing an eye to it that is thinking a lot about how do people who don't come from the blockchain and crypto world benefit from this technology.
Very interesting. And so it's truly a multidisciplinary team, which I think is important if you're going to be building complex global systems designed for everybody. And as an architect, Jonathan, what does your week or your day or your month look like in terms of the types of activities you get up to?
Yeah, I certainly couldn't describe it on a day-to-day because it varies from day to day. So like I said, I've actually, coming from outside the blockchain world, I've intentionally kept myself with that perspective. And I think the contributions that I've been focusing on are about the technical side of how everyone else who isn't from purely the blockchain world benefits and experiences Midnight. That includes the tokens and their distribution and management, people paying for transactions and thinking about the capacity of the Midnight network to do useful work, and especially the developer experience for developers who want to come build things on the Midnight platform. How do sort of traditional developers who don't know a lot of cryptography or anything, how do they land there and do useful work and build cool things on it? Is it really possible to not be super knowledgeable about blockchains and crypto and build Midnight applications? Has been a lot of my focus.
And so building on that, how would you explain the Midnight architecture to somebody who's familiar with technology maybe, but who hasn't come across zero knowledge and blockchain to date?
Well, I think there's a version of it we can do that is kind of simplified. I'm not going to dive into the little nitty pieces of all the things going on in there, but that show the sort of big pieces that you need to know about if you want to build something on Midnight. And so I'm going to point at an architecture diagram here, but you'll see that it is not a super complicated one, I hope. And the pieces are colored and shaped to convey the important parts, I think. So this is the architecture, and I should qualify this as of the current DevNet. And I may point out some places of things that might change, but any of it is potentially subject to change between now and actually arriving at mainnet, of course. So the first things to know about, and you can see here, is there's a compiler in this picture. That's kind of interesting. And there are things that are input to that end up in the application that aren't just, I wrote the application and that's all there is to it. So the things you write to build a DApp, and we'll see this concretely in just a minute on Midnight, include a contract that is your Midnight contract, and that's written in a language we call compact. Now, I hope it is small, but we don't call it compact because it's small. We call it compact in the sense of making a compact with someone. So we have this compact language, and that flows through a compiler to produce TypeScript output and some of the keying outputs you need for the cryptography side. You write the rest of it in TypeScript. And so the compiler produces, in a sense, a custom API for your contract that then you can write TypeScript code that calls into that and does things with your contract, as well as using the rest of the platform. And so the DApp that actually runs doesn't carry the compiler with it. That doesn't ship. And in fact, it doesn't carry the source code of your contract with it. Instead, all of that goes in to make the DApp, and it runs in a browser. Typically, we can also run on Node.js on a desktop system. On the other side of that, the kind of back end is more the traditional blockchain shaped stuff, where you have, some nodes out there that are running the big distributed blockchain spread all over the world with lots of block producers running them. There's the main fault-tolerant network that are block producers. And then there can be many nodes. You can run one on your own system that's not one of the ones that's really voting. It's just an observer node. And then there are indexers that watch that and turn the data into a useful form that dApps can subscribe to. And so I've drawn here the sort of main observer node and an indexer, and I call those the client services. And those could run on a laptop or off in the cloud or on a desktop or a server or anything. And on this side is the DApp that runs typically in a web browser. And that could run on a mobile device, your laptop, or again on a desktop. There's one piece in here that's interesting, and it has to do with what makes Midnight special, which is that there is information that may pass between the user and the DApp that is important to the working of it all, but that doesn't go out onto the network and doesn't go out into the Midnight blockchain, and yet it's used by it. And for that, we have this thing called a proof server. And I didn't put that out here in the cloud. You notice in my labeling of where might this run, I didn't say cloud, because the information going between your DApp and that proof server includes your private data. And we'll talk about that split in a minute. And so the idea is we've called out this part that says, look, I'm using this private data. I can prove to you I'm using it the right way. The proof server takes the information from the DApp, says, okay, I can certify that. And then what goes out into the cloud is the certification of that. And so you could run this right alongside the DApp on your laptop. And we're also exploring things. I've done some prototype demonstrations where I run this maybe in my house. But as I walk around my house on my mobile device, I'm not running the proof server there and it's connecting it to something in my house. So that's still an area that's being explored, exactly how that runs. But this is all working right now. And that's kind of the big shape of the architecture.
Fantastic. Thank you very much for that. And zero knowledge proofs, as you mentioned, and data protecting smart contracts, from what we can see today, are a paradigm shift in how developers approach and build applications. Could you give some examples, or maybe just build a little bit more on what you said there in terms of how does that enhance data protection? How does that enhance security when it comes to building practical applications?
Yeah, I know some people, you might ask this question and they would talk about ZK proofs and the way all of that works. I'm not going to talk about that. I think that's not actually the useful direction to go. I think the interesting thing is that there are patterns all over the place outside of Web3 in the normal world where you do get this public-private split. And I know you yourself, Anthony, have pointed out that to do useful things in the world, you can't keep everything private. Like being in the world requires public interaction. I'll give two examples that I think are great. One, I'm a parent. I have children. And when I send them off to school or to some summer camp, I'm always filling out forms that give information about their health and their healthcare providers and allergies and any medicines they have to take. And in the US, where we don't have public healthcare, I have to give information about their health insurance and identity numbers and all of that. And their school needs that in case something happens. In fact, their teacher needs it, and the front office needs it, and the summer camp needs it. By having to have that, the school is suddenly in the position where they are responsible for a lot of important private data. They don't even want that data. They don't want to be caretakers of my private healthcare information. And yet to take care of my children, they have to know that that's available. So this is a place where there is some private data that the only way they can use the public side of it is to own that private data, right? And that's not what we want. We want to keep that separate.
It's a good example. I appreciate one. Do you have another?
Yes. So here's a one that is actually my favorite one. So in the US, when you buy a house, and I assume it's a similar shape in most countries, when you are at the point where parties have agreed, I'm going to sell my house, I'm going to buy this house, and there are all the different parties involved, you go to a meeting and it's called the closing. And you are closing on this house. And at the closing, you have the buyer and the seller and representatives from the banks that are involved on both sides, and usually some attorneys, and there's all of this stuff, and there's a lot of paperwork. Each of those parties there is contributing information into that closing because they have to share information. It has to be made public and shared among them. And yet they're also holding back a bunch. So for example, here there's a thing called title insurance. So if you are selling me a house, then I want to know that you actually own the house you're selling. You're not just lying about it, and you have the rights to sell it to me, that you really hold the title to that house. And so a title insurance company is going to go out, they're going to dig through public records and private records, and I don't know what all they dig through. They find a bunch of information, and they come back and they say, Anthony really does own this house, and he really does have the right to sell it. And we're going to certify that at this closing, and we're even going to put money against that and say, if we're wrong, we will pay for any losses that occur because of it. Now, they don't share into that closing all of that information they gathered. They just share the certification that says, we assert that Anthony owns this house. And it's the same way, the bank, I'm going to buy the house. My bank doesn't tell you what all my assets are. They just say, we certify that Jonathan has enough money to buy the house. Enough. I'm going to tell you how much, we're going to tell you it's enough. That shape, where we have these different parties coming together, sharing filtered, limited information into a shared information space with a bunch of private information that isn't shared, that pattern is just all over in the business world and private world and healthcare world. And that shape is what Midnight supports. And so my biggest dream vision is that people use Midnight to build support for those kinds of interactions in the real physical world.
Excellent example, Jonathan. Has spoken like a true architect when we talk about patterns, but I think that's super important because those are the prescriptive requirements. For when we see validation required, but where the actual data doesn't need to be shared, it's just a certification or a green or red status, that's a place where we can start adding more data protection. We can reduce the burden of data governance, and we can just make things flow more easily. So I'm with you. Let's get into the demo. Jonathan, could you take the audience through an approach to building a DApp on Midnight and point out maybe some of the important features or the considerations as you go? Would you be up for that?
Sure, absolutely. I'm going to show some code here even. So let's take an example. So it's an example I'm going to talk about that is in our tutorial. We have a tutorial that walks you through learning to build Midnight stuff and kind of takes you through the pieces and invites you to do some things and gives you the answers. I'm going to skip past the first parts of that tutorial and take you to part 3 of the tutorial with an example that fits the pattern I was just describing in a way, but in a very, very simplified form. We're not going to build the DApp to buy and sell houses yet. Exercise for next time. It's an example I like a lot. And if you think about your university department or your business office, often there's some kind of, back in the olden days when we all got together in person, a billboard up, a bulletin board up. It was often made of cork and little push pins, and someone could put up a note that says, hey, everybody, there's a party at my house this weekend, or my children are going to do a play at school, everyone come see it. And they put up a piece of paper with that information and the date and time, and they tack it up on the board. And usually there are some spoken or unspoken rules about who's allowed to post things and what kinds of things you're allowed to post and who can take them down. And so, if I'm the one who put the thing up, then obviously I can come take it down whenever I want. And in a real office, there's usually rules about if it's been up for 2 months, someone else can come take it down. But let's go with a really super simple version of that, right? Where this little tiny bulletin board, my daughter has one of these in her room. It just has enough room really for one sheet of paper. You can tack up one thing. Let's just imagine that scenario. But we're going to put it up in the office. And we're going to say, whoever posts something, if it's empty, anyone can post it. If the board's empty, you can post, Anthony, I can post, anyone can come tack something up. If there's something up, only the person who posted it can take it down. And let's leave out all the rules about, if it's been up for such and such long, then you can take it down. So the poster can take it down, no one else. And if it's empty, you can put it up. So it's really a 2-rule system. Empty, anyone can post. Don't care who you are. You're walking by, post something. Non-empty, the person who put it up can take it down. Okay? Now let's suppose we do this online. We go, I want to build an online version of that. I'm not coming from the blockchain world. I say, I know how to do this. I'll build myself a little web server, and someone can come along and I'll post the thing online and it will display whatever is posted. And if you want to post something, you click on the web page and you type in some text and it shows up there. And then you come back later and you want to take it down. Wait, who can take it down? How do I know you're the person who can take it down? And you can say, well, really, I'm the one who put it up. Well, did I trust you? I mean, maybe you're just tearing down my stuff because you don't like my party this weekend. Well, this is where typically the non-Web3 world, we'd say, no problem. We'll give everyone a username and password. And Anthony can log in with Anthony's username and password. And we'll say, only Anthony would know the secret of that password. And so you put the thing up and you did it with your username and password. And then we record that was Anthony. And you come back later and say, I want to take it down. You type in your username and password, and then you can take it down. Your password went across the network doing that, and my server knows your secret password in order to check it. Now, you can do things with hashes that pull that back a little bit, but let's go way the other direction. What we can do on midnight is a thing that sounds impossible. We'll say, Anthony, you check for yourself that you are the person who put it up. Tell me, and we'll trust you. Well, not quite trust you. You send me a proof that you're following the rules of this game, and we'll trust that. That's what Midnight does. So we take, and I want to put code up here, we take these rules, we write them in our contract language. So this is some actual compact code that I'm sharing here. And it implements the system I just described, where we can actually build what I said, where you won't have to send any password or log in, and you'll be able to say, no, really, I'm the one who put it up and I'm following the rules and I checked it the way I'm supposed to, and you can send us the proof for that and we can make it all work.
And Jonathan, this code here looks a little bit like JavaScript. Could you talk a little bit on Compact?
Yeah, so Compact is, we've argued among the developers the right way to describe it. It is not TypeScript or JavaScript. The main APIs we generate for it are for TypeScript. And so what we've tried to do is design something that isn't TypeScript because it's not. It's doing different things than TypeScript, and it produces different outputs, like the keying material you need for the proofs. But it's intended to be close enough that it's not jarring as you go back and forth. So you might call it TypeScript inspired.
Got it. So anybody who's out there who has experience of developing with JavaScript or TypeScript would find Compact fairly intuitive.
The shape of it is going to look familiar to anyone who's done Java or JavaScript or TypeScript, or it looks like most kind of languages that are out there these days. More like those than Python, probably. But yeah, it's not going to be foreign to anyone. So a couple of things you can see right away. You can define some helper types. And I already said, when trying to describe the problem even, I said the board could be empty, could be vacant, or it could be occupied. Well, let's give ourselves a type for what is the state of the board, vacant or occupied. So we defined that. Now, in the blockchain world, we talk about what's on the ledger. But if you're defining your own contracts here, we need to say, here's the shape of the data that I need on the ledger. So anything that I say is on the ledger is public information. It's going to be posted out there on the blockchain and the whole world can see it. And I will have to say, coming as an outsider to this world, I always thought of blockchain stuff as everything is secret and nobody. And in fact, of course, what I learned coming to it is it's almost the opposite. Everything on a typical blockchain is completely wide open and public. And in fact, the challenge is how do you not just make everything seen? So what you can do in Midnight is you can say, here's the part that I do want to be seen. This is like the information you put into your closing at the house transaction. This is what I want to be seen. So obviously we want our message to be seen. So here's the message, and we're saying, here is this message. It's a string. It might be there, maybe. And it's one that can change. We say it's a cell. It means I can change the value of it and drop new values into that cell. It's a holding area. I'm not going to go through the details of Compact right now, but you get the kind of the rough idea. The state is either vacant or occupied. So we have a cell that can hold the current state. And the poster, I'm saying, is just a collection of bytes. Now, that's the thing that's going to represent you. This is Anthony did this post. This pile of bytes represents you. But this pile of bytes is not going to be able to be linked back to you. So we start off and we say, when this contract is deployed on the blockchain, it starts off vacant. There's no message posted. And I'm not going to talk about the counter right now, but I'll say this. The idea is by incrementing that counter every time there's a new post, we can add a little bit of information that changes every time. So even if it's you posting again, we can hash that number in, and people won't even be able to tell that it's you the next time because it will mix up all the data. Okay, now here is some of the amazing stuff about Midnight. It's this thing that says witness, local secret key. Now I didn't define this. When I say local secret key, I really mean this is going to be your local secret key that will never leave your machine. You won't submit it anywhere else to be checked. We didn't define it here. You notice there's no code around that. So what this means when we say a witness in a compact contract, it means that often your TypeScript code on your own implementation of all this, you can implement that function. In fact, you and I could both use this contract to post things to literally the same deployed contract on the blockchain and have different implementations we had written in our own separate code for this function, and it will still all work. It's that independent from the public space. And then there are things called circuits. Now they're called circuits for cryptographic reasons because the kind of system that's used to represent the work here and the proofs about it uses things called circuits. And so the part of the operations that say, here is how this has to work that is public is described in these circuits. And they look like normal functions. I want to post a message and I'll fill in some information. What's interesting is this assert line. And this isn't assert like check my code for bugs. This is a truth about the system, and this is how we encode those rules. So remember I said rule 1, the board is vacant, then you can post. Anyone can post. So let's say, hey, if someone wants to post, the state better be vacant. In fact, if it's not vacant, you can't post. You have to take down the old thing first. So if someone's doing a post, we say the state better be vacant. Otherwise, we're going to say, hey, you attempted to post to an occupied board. This rule, by putting it in here, is built into the deployed contract on the chain in a way that can't be violated. And the chain will enforce that. And if you get past that, then we can say, okay, then we'll put the message up. We'll say the board is now occupied. And this bit of fun right here that says, who posted it? Well, we're going to call this function public key and pass it the local secret key. But public key is going to hash your secret key into some other stuff and some text and that instance counter. And so the thing that goes up there is just some garbage bytes that's derived from your secret key and from the counter and from this, but in no way that could ever be traced back. That's what goes up there. Now, here's the fun part. You go to take the thing down. You want to take down a post. Well, first of all, we do some obvious stuff. It says you can't take it down unless it's occupied. Otherwise, you're doing a silly thing. So we can say, if you're trying to do a takedown, it better be occupied. Otherwise, you try to take it down from an empty board. And then this part. If you are the one trying to take it down, you still have your secret key. We can recompute that same number, that same pile of bits, and it better, in fact, be the same instance. So if this is the 19th post, it's going to be the one, we're going to compute a different pile of bits for the different number of posts. This is the 19th post, then it's going to say for the 19th post. It's going to say the public pile of bits out there better match that. And so the thing we send onto the network is the check of that. And in fact, we don't even do that. We just compute it, check it, and say, we did it. And then the proof that we executed this is what is shared up with the world. And then the operations on the other side of that say it's now vacant and now there's no message up there and this thing returns the prior message goes up. What happens about these circuits is the proofs that they were executed following these rules that are built into the deployed contract. That's what is shipped up there. That's what's verified by the blockchain. And so you never sent your key up to be verified. This thing just says it followed the rules and we have a proof of it.
Very interesting. So fully automated, fully encrypted, and your key, your sensitive data, never leaves your machine.
That's right. The only thing that goes up is the public information that we wanted to be public and the proofs that we followed the rules that were also public. So if you want to participate in this contract, you say, hey, I want to post something. You are effectively saying, I'm willing to play by the rules. And the system goes, okay, I'm going to check that. So that's the contract. That's the rules of engagement that we've set up for this. But what we should be asking ourselves at this point is, what is the software we can build around this? How do we get from this sort of agreed contract of behavior to some working software, to a program around it? How do we make this bulletin board something someone could use? Well, let's look at the code for that first, and then I'm actually going to run a demo of it. So we use this as one of our tutorial examples. So you'll see in this code some exercise 1, exercise 2 kinds of stuff. And if you go through the tutorial, you'll do it. But you can see we're just writing some TypeScript here. Because remember, what our compiler does is it takes that contract and it generates a custom API for using that contract from TypeScript. So here in this TypeScript, remember we had that witness. That was the custom part where we can do something different on each implementation. And I've said, what I'm going to do for my secret key is just an array of 8-bit bytes. So there's my uint array that I'm going to call secret key. And that's what I defined here. And I defined a function to pull that back out. And then when I actually write the code to deploy the contract, now, of course, most of that is part of the API we provide. We just say deploy, but we need to provide some of that private state to go along with the public state that we've all agreed upon. And this private state, we say here is this deploy function, deploy contract. That's something provided as our Midnight API. And one of the arguments is the private state. And I've said, well, just get me a private state for this. And here is my definition of get private state. First, we have a thing that automatically will store it in some browser storage for you. But if I don't have one, just make some random bytes as my secret key. Now, it's a little subtle to realize that, of course, if I run this and you run this, we're doing completely different things. So we're able to run my version and your version and get different random bytes and yet have a working contract we've agreed to. And that's part of the magic of Midnight. So having done that, we can say that was deploy. I can have a contract out there. And then when I want to do something like, say, post a message, you can see, remember, post is one of the circuits we defined in the contract. We wrote that in Compact. And yet over here in TypeScript, I can just call it as a TypeScript function, as a method on this class, because we generate that API so that anyone who knows how to write some TypeScript code can call the post function and pass the message. And it feels like it's just there magically for you. So by doing this kind of thing, I can build a TypeScript application for a Midnight decentralized app against a contract that I've done. So now I'm going to take this code. I'm not going to do the tour of it all. Go do the tutorial yourself to learn more about it. I want to show you what it looks like when it's running to see that it actually works. And so now you see that I have this running. So what I've done is I've compiled this TypeScript code. I have it running in my browser, and I have a bulletin board app here that some of our developers have put together. I, by the way, have my Midnight wallet here, and I can see that I have some test dust. I have 4.9 test dust here in my wallet, so I can do some things with it. So let's try it. Let's actually deploy a bulletin board. Now what this is doing, it says, oh, it's going to spin some of my dust to do it. Yes, I'll sign that transaction. Off it goes. This is talking to the real Midnight network right now. It's going out. It's creating a little proof that I have a valid contract to deploy. It's sending that out to the network. The different nodes are coming to consensus that it's all valid. And when it's done, I will have this contract deployed, and I could share the address of it with you, and you could post something to it also. And there it is. So now we have a contract deployed, in this case, our bulletin board contract. Up here, if I want to, I could copy the address of that contract, send it to a friend of mine. And like I said, this is the real DevNet. You could get on, your friends could get on, and we could post messages here. Remember, part of our rules is I can post anything as long as nothing's there, and nothing's there yet. So I can just say, post that. Now, once again, it's running a contract. It's connecting to the proof server. If you remember the discussion we had of the architecture, it's making a proof that I'm really calling the contract, following the rules. It's going to check on both my test run of it and on the real network that there was nothing there already, because remember, that was our rules in the contract. It has to be vacant. It will go through, submit a proof that I followed the rules, and the network will say, yes, you can post. And now we have the actual posted message there. And if you connected to the same thing, you could actually get it. You know what? I'm going to be a little crazy. Copy this address. I can't, you don't see the whole thing right now. Do this with your friends, and you could actually connect to this one. Now the question is, could I post again? No, I can't post again because that breaks the rules. But I am the one who posted it, so I can take down. And this was that bit of magic that says I don't have to send any kind of password up, because the contract is going to verify that I am the poster, and it's going to send a proof that I followed the rules, which means I can take down this message. This is another transaction, spend a little bit of dust. And the proof is going to go up there and say, yes, this person really did verify that it was the person who posted the contract. It was the same bytes. We don't even send those random bytes we generated. We send a hash of that no one could reverse. It verifies that it matches what went up there before, and I am allowed to take down this message. And then we have a working bulletin board. This is the basis of the kind of thing you would do to have a full working decentralized app. You just extend it and extend it. There it is, it worked. That is Midnight at work. That is contract, code, working web app. We're going.
So there we go. Great to see. Something that should feel familiar to most developers can be built in a language that's familiar to the large majority of developers out there in terms of TypeScript and JavaScript, is simple to do and works within seconds. And all of the private data remains on the system of the owner or the user, which I think is super powerful. What is the draw for application developers to make use of a blockchain or technology like Midnight?
Well, I hope I've conveyed some of the kind of possibilities, kind of the hand-wavy big dream possibilities of the kind of shapes that happen in society that way. And we've seen how a very simple version go together. I think the draw is to do something a bit more than our toy bulletin board example and move in the direction that building in this kind of shape that I think is so prevalent in society, and build using these tools. So I think the draw is, hey, there's so many places that I see these patterns out there in healthcare, in records management, in games even. I mean, people do this thing where, you play Battleship is one of the fun examples people like to show, where it's like, I know where my ships are and you know where your ships are, and we're playing a game. How do you know I'm not lying? And this kind of smart contract can say, we know you're not lying because the rules of the contract say you're not lying. And my system knows where my battleships are, and your system knows where your battleships are. And we never share those, and yet the system can say that you're following the rules. Or the other examples, that there's so many that come up in the area of certifying identity. And so I know that we've talked to people, some developers who are interested in doing that already, and we'd love to hear more examples where people can do the identity-like thing, where something has all the information that proves my identity in a deep way. And I have some other app out there that I don't really trust that much, other than I want to tell it that I'm over 18 or that I'm a US citizen or what. There's things I want to say about myself, and someone has enough information to assert that it's true. But I don't want the thing that's receiving the assertion to have all that private data. So there's all kinds of things of that shape that even in our DevNet phase, you can start building that kind of stuff and trying it out.
Very good. And as we wrap up our discussion, Jonathan, what advice would you give to developers or organizations, given that you're somebody who's come from Web 2, who's relatively new to the world of blockchain and Web 3? How could they best prepare to make use of Midnight or to build decentralized applications with data protection like you've just described?
Well, so one thing is, go through our tutorials and play with it and discover that it's kind of straightforward and not scary. That, oh, look, I can just build that and it works. That's kind of cool. What else can I do? The kind of play with it like Lego. That's the fun side of coding, honestly. That anyone who writes code, this is the best thing about it. Let me play with some stuff. So it's, I would say, do that. If you're an institution, get some of your developers to play with it and learn that it works. The parts that are the real learning side, it's not so much the crypto, it's the learning to think in terms of privacy and public data. And that split, where I kind of said, oh, look, we want this in the public space and this in the private space. Developers are used to thinking about the data modeling they need to do. Here's the kind of shape of the data structures I need. They're a little less used to, oh, but these data structures are the ones I need the world to see, and these data structures are the ones that I don't need the world to see. And so kind of practicing that. And then some of the patterns that we have even in our learning website about there's particular coding patterns that are kind of similar in shape to public-private key cryptography. Not that you have to know the crypto side of it. It's the thinking about the public-private crypto of, oh, I know this and you don't, but I can still communicate about it. or there are these patterns that are called nullifier patterns, where you add something to a set to say that it's used up. There's certain kinds of coding patterns that already exist out there in the world, but they come up more often in this space. And getting familiar with those makes you a better programmer in this space.
So ultimately, it's about the patterns. If you've already got the language experience, if you've already got an understanding broadly of where data protection is important, get into the DevNet, get into the docs, get into the testnet, start becoming more familiar and tinkering.
There's actually a lively community out there. We have this Discord, and there are people, and they're helping each other. One of the coolest things to see as an architect is to see that we already, at the DevNet phase, have developers that are helping each other and answering each other's questions, and they're good about it. So jump in and get involved.
That's really great to hear. And that's a wrap for today's episode of Unshielded. A huge thank you to Jonathan Sobel for sharing his insights and expertise on the foundation of data protecting smart contracts, and a really interesting walk through a live DApp on Midnight with the bulletin board. If you're inspired to learn more or start building on Midnight, be sure to check out our documentation and resources, docs.midnight.network. You'll find the tutorials there, you'll find the documentation there, and more details around the Discord and how you can engage with the rest of the community. If you've enjoyed this episode, be sure to subscribe, rate, and leave a review on your favorite podcast platform. And don't forget to follow us on social media for the latest updates and more exciting conversations in the world of blockchain and data protection. And until next time, stay curious and keep exploring the potential of technology to transform our world. Unshielded is brought to you by Midnight. To find out more about how the Midnight Network is helping everyone to build a more equitable and accessible internet, visit our website at midnight.network. And remember to search Unshielded on Apple Podcasts, YouTube, Spotify, or wherever you get your podcasts, and be sure to subscribe so you'll never miss an episode.